I'm honorable presenting my paper entitled A Study on In-House Engineering Software Structure, Improvement Using Design Patterns. Actually, I should be there, but because of COVID-19, I cannot attend the conference. So thus, I'm recording my presentation, and I will show my, I will explain my paper. If you have any question, please let me know. I will apply as soon as possible. Today, I'm talking about a study on in-house engineering software structure, improvement using design patterns. Mm, many people know the software engineering. Software engineer is a discipline that learns systematic approaches to software development, operation, and maintenance. Also, software engineering handles various methods to develop a high-quality software by minimizing cost within an optimal period to improve the productivity and quality of software. Many people know about the software engineering. However, I just explained for someone who didn't know, who don't know the software engineering. Why does software engineering needs to develop software? Actually, when you studied in the university, you can have you have many homework from professor. But programming homework is composed of under 10,000 1,000 lines code. Actually, some heavy project, heavy homework. It is composed of 2,000 or 3,000 coding lines, but it is not easy. It is not difficult to maintain or upgrade the software. But when the number of program coding lines exceed 10,000 lines code, uh, at the time, very side effect and problems in maintenance, which even a professional developer could not expect to arise. Additionally, when software developers develop software not for themselves, but for other people, or software that are used by many people, various unexpected errors and bugs arise during tests and actual uses, even though they haven't been developed with perfect design based on rigorous requirement analysis. So, as the software is more complex, software the needs of software engineering is increasing. Do you understand? In-house engineering software. I'm talking about in-house engineering software at this page. In-house engineering software has been developed by internal developer for analyzing dynamic source structure or calculating performance in the company. Actually, big structure or heavy structure this structure is made by a heavy industry. So we are talking about heavy industry software. Initially, this software was developed simply for myself, but someone else, not for many people. For whatever reasons, as the number of other users are increasing, various unexpected errors and bugs arising during tests and actual uses, even though they have been developed with perfect designs based on rigorous requirement analysis. Particularly, additional coding lines are added to the initially developed software to correct errors and bugs that are generated from unintended operation by various users and to implement demands for improvement of performance from users, and this makes more complex. As the number of programming lines that compose software increase, the structures of software becomes more complex and software engineering approach becomes necessary. When software undergoes this process, it may be commercialized like a citrus house can, developed by the Korean Register of Shipping, but it may also be used in company without exposing it externally, and this is called in-house engineering software. So in-house engineering software covered in this paper are design process necessary in product development stage that were developed in languages such as C or C++ and or Fortran. In the 1990s and 2000 years, when the general purpose analyzed, such as ANSYS, Abacus, and engineering software were not common. They are still being used if they cannot be replaced by conventional software function of it of if conventional software is expensive. Even today, there are cases of in-house engineering software if required analysis process cannot be provided conventional software. So the main reason the using of in-house engineering software, conventional software is expensive or doesn't handle the function that the company wants to calculate or simulate. But the problems of in-house there's problems of in-house engineering software. But the biggest problem of the in-house engineering software is they're incompatible with the current available operating systems since they were developed a long time ago. For example, the popular analysis software of Shilamet Corporation was developed in Fortran on the Microsoft Windows 95 operating system and has been used until now. Even recently, many personal computer uses Windows 10 operating system, but some in-house engineering software is operated by with very old versions. The scan problem comes from the software that was designed and developed by focusing on the functional aspects without software engineering approach. In the development field of in-house engineering software, object-oriented concept, patterns, and frameworks were not common, and most developers had a background in hardware, such as mechanical engineering, and a background in software. Thus, software was developed without proper design document. This also means that when a former developer leaves the company, the successors has a lot of difficulties in understanding the programs, maintains programs. So in this paper, I was talking about talking about the migration of the in-house engineering software called Namhyun, which was developed in the early 2000 years by Daewoo and Marine Engineering Corporation. By applying software engineering approaches, we designed, developed, applied, and propose a pattern that can be applied during upgrades of in-house engineering software similar to Namhyun. In this paper at this time, I was talking about design pattern. Design pattern was the first used in the field of architecture. It was applied the first time by Christopher Alexander, an architect in the late 1990s. Each pattern describes a problem which occurs over and over again in our environment, and then describes the core of the solution to that problem in such a way that you can use this solution a million times over without ever doing it the same way twice. Ultimately, the design pattern is not invented but discovered. In real life, it takes many observations or attempts to discover pattern And we discover certain pattern by continuous observation attempts. So design patterns, the meaning of the design pattern in this paper means a summary of the problems experienced by many people in the development process and their solutions. At this page, we are talking about design patterns. Actually, GOF design pattern is a famous design pattern. Many developers prefer to use this GOF design patterns because much research had been conducted, and if someone use these design patterns, they can upgrade the software architecture, and they they can improve maintenance and the user. Chief design pattern was first developed by 4 persons, actually Eric Gamma, Richard Helm, Ralph Johnson, John Blizzard. Actually, I don't know how to pronounce these authors. Anyway, in 1994, and it's a pattern that has been actualized and systemized in software development area. They organized the design pattern into 23 types, classified them as creational, structural, and behavioral. You can see the 23 patterns is divided by 3 big components. So the design principle then leads to, sorry. So the design principle then needs to be followed efficiently, apply various patterns which are discovered and organized from experience gained by previous developed, and maximizing their effect. This is called the solid design principle. Solid design principle is the abbreviation of a single responsibility principle, or closed principle, list scope for substitution principle, interface segregation principle, and defenders inversion principle. Actually, at this time, we don't talking about the five design principle because we don't have enough time. So we just I want you to read for solid design patterns personally. So at this page, at this time, I want to talking about the analysis of the existing machine, old machine in developed 2004 years. Actually, shifts under IM regulation 8.601 revision 15 must be prepared, maneuvering information quickly and provide it to the ship owner. Based on the regulation, a VLS poster must be prepared and displayed on the upper page. For this reason, the Shipbuilding and Marine Engineering Corporation, which for now, I just call it TSME. TSME means the Shipbuilding and Marine Engineering Corporation. TSME developed machine software in-house in the early 2000 years, actually in 2004 years, and provide maneuverability of ships to the ship owners in a form of MIB using the figures generated from the data obtained through leadership tests and the result from self-defined maneuverability simulations. This picture is figured by old machine. That means this figure shows the performance of the ships and starboard and port side, and they give factor to for the performance of the ship. They just calculate and finally brings out the result of simulation. And finally, we use this data. They draw these figures. So it means this ship, some ship, a ship can sail with this uh, with this with this performation. To simulate maneuverability of a ship, they adopt a modular model where the force and moments applied during maneuvering of the ship are separated in terms of hull, rudder, and propeller. If the data required for the ship maneuverability simulation include the principal dimension, resistance parameter, propeller specification, rudder specification, RPM specification of the ship engine, along with stack test and wind coefficient data obtained through leadership test. Using this base information, the program performs the 18 simulation tests for various vulnerabilities such as initial turning, course change, and turning sag, and outputs the result into the text file. This is the input data screen of old machine. This power, this input screen required the coefficient data, the coefficient data of the wind. There is a software engineering lesson problem. A functional composition of a machine is as follows. So you can read the software engineering analysis of a machine. Actually, the machine is composed of a machine dog and a machine view. Machine dog in the machine dog calculate and simulate and finally generate the result of the simulation result in a text files, and machine view figure the features. It shows the performance of the ship with the text files. So the machine is composed of a machine dog and the machine view, and the machine dog is calculated, simulated the result, and the machine view just show the performance of the ship with the result data, actually text file. So the result file in text file, it shows the meanings of at each one in at this table. Machine has been developed in C++ and MFC. However, it has been developed by textual procedure oriented approach rather than object-oriented approach, since it was developed by a non-professional software engineer. So each function has been developed separately through implementation method for each function to ensure that there is no overlap between functions. However, side effects arise from the structure in which the data input for the simulation are directly referenced as a part of the simulation process and global variable like our result type. And in addition, it does not separate the user interface from the control logic. Thus, it has a structure affecting the entire program, including the main functions. And there's an additional function, simulation parameter changes or visualization is added. So this is a package diagram of class diagram of the old machine. So actually, machine dog and the machine view is a big component of the old machine. There's a requirement for performance improvement of the machine. Just you can recognize the requirement from the DSM. So you just read the requirement. At this time, I didn't don't talking about the requirement because I don't have enough time. At this paper, I was talking about the improvement of machine with design patterns. Actually, we have the separation of control logic and user interface. So in the first development, machine view was developed in C# and it utilized the system code provided by C++ to directly call machine domain, C++ for real-time synchronization and the data exchange between the two systems. The user input data and the simulation result data exchanged between machine and machine using ASCII type text files. By using ASCII type text files, we solved the side effect by naturally separating the user interface and control logic by separating the programs with different mutual development languages. However, it had a problem with generating a text file for exchanging input and out files. When users run the simulation, it had a problem such as a slowing down of machine program operation due to generation and deletion of the text file and possible leakage of data files. So finally, we used the marshalling method for mutual data exchange between the new machine view. We then add the user data input interface and machine dog, which only performs simulation. This table shows the marshalling method. Actually, C# calls the C++ this execute functions, and when the C# called execute functions with I send data, and finally the send and return data received I return data from C++, and they use this structure. They can each program can exchange the data. Actually, older Nashim uses just the text file, but it has many problems I just already mentioned. So this DSME decided to use Oracle, which has been internally for the base database. But sometimes the machine cannot connect to the internet because machine has been operated in the ship in the sea. At the time, they cannot use internet. So at the time, the machine uses Microsoft as a database during the marine operation to enable it of network. So machine has to use two type different databases. For this system, we classify the two SQL statements using a factory pattern. So a factory pattern allows machine uses two different types of the database without any problems. So, and we also will implement value object and data access object pattern to develop this SQL statement. This is a class diagram of DB help factory patterns. This is a class diagram with factory pattern. When if the machine uses factory pattern, they don't have any. They reduce the redundancy and they strengthen the integrity of the SQL statement. To get screens for each menu in the ordination are composed of pop-up dialog screens. In addition, to generate the MIB booklet, approximately 2 and 3 simulations, including ship trajectory, time history diagram for each time history, and diagram for each of ballast and loaded condition, must be performed and graphs must be drawn using results. Thus, it has minimum 100 steps in the details. A worker must insert the output figure using Microsoft Word to prepare an MIB. Thus, it is difficult to check at which stage the simulation is at. Particularly, the simulation time account for more than half of the entire process time. And since it is difficult to check the result from a simulation process in stepwise, it can delay the entire process time due to overlapped work. So in using automation, with much time to to so anyway, people uses automation cause cost problems and need more much time. So they have to reduce the cost and using time. So to solve these problems, the new machine has two views. Control on the left side of the screen and matching the screen, which shows this shift space specification data into screen, each simulation, and each resulting figures on the right side of the tab page control. So when a simulation menu is selected from the previous screen on the left side, details appears in the tab page on the tab page control on the right side. And a process complete from the detailed tab page of the tab page control on the right, and it is saved completion of a step process is displayed on the right tree menu. Finally, when all processes are complete, the user can confirm that all process has been complete for the entire menu. Further, even when the program is closed and restarted in the middle of the process, it disables work performance on the previous process and allows the user to check, thus minimizing inconvenience of users. For a commonly required function, we designed to process using a common button to increase the functional convenience of the users. So at this code, key point is 21 lines. Actually, using this structure, case by case, when you as the cases are adding, the cases is adding to the tab pages or too many. Code is more complex, so it has to be solved by any other method. So to solve this problem, we separate the function of main from screen into main handler, toolbar main handler, and tree handler, as is shown in next figure. Utilize the single page application type control for various changing screens to minimize the system load from multiple pages. Further, it processes screens changing from common button until control selection. It declared tab interface and utilized the abstract tab in accordance with the selected simulation to implement the tab simulation. The initial implement version from existing older machine had close to 40,000 lines of code for mining app, resulting in difficulty in maintenance and repair. However, as we applied as shown in next figure, developed code line for each class has declared to 1,200 lines to significantly reduce time it takes to correct bugs and to improve performance. As we only display tab simulation, however, the entire program included 15 ship-based data into screen as one simulation screen, one graph screen, and a screen to automatically prepare the booklet, and tab simulation and tab graph had not most branch paths. So this is a solution to reduce the cost and the complex. So we use this iTab interface and abstract. We add the main handler and the toolbar main handler and two handlers. So tab simulation just only one screen, but it has many other screen. So it results in complex, but using this architecture, we reduce the complex of this software. So we test for improvement to user convenient by nation operator. Actually, all the nation is about 9 on our 9 months. However, the donation test needs for 4 months, 4 men per hour. So it reduce the cost and reduce the time. Because the donation provide the convenience for the users. So for this project, the nation users has improved their performance and their load, lessen their load. So finally, most in-house engineering software has been developed due to the necessity of functions that are not provided by commercial analysis and simulation programs. But due to this characteristic, they are used in a specific department in a specific company because they are mostly developed in small scale rather than investing a large budget and workforce. Also, in most cases, they are developed by internal employee who has majored in mechanical engineering rather than by a software expert. Thus, they are designed and developed focusing on functions, and there are many cases where the latest software engineering approaches are difficult to be applied. So in this we applied the various software engineering technology in process of improving function of the machine, which has been developed by the SME in 2004 and has been operated. We increase the usability of the source code in machine, increase the convenience for maintenance and repair, and prevent leakage of internal technology by applying machining method to prevent external developers for the user interface and to the individual developers from accessing the key algorithm developed by the internal developer. Also, we propose enhance pattern to easily improve the function and apply software engineering software pattern on software that can extend input and output data in text file among in-house engineering software developed in C++, C, or Fortran. So enhanced pattern has been composed to allow manufacturing industry that use in-house engineering software to improve the functions. Thank you for your attention. If you have any question, please email me. I will reply as soon as possible. Thank you.